So this video here is on making the flue for the Chiminea. I'm going to be making a stainless steel flue out of 1mm stainless steel sheet, and that's because the one I'm making is a demonstration unit, and we wanted it quite short at 500mm long, which will be the length, because it's going to go to trade shows and it could get damaged. So slightly different to what you as students will be doing. You will be making it out of 0.55, 0.6mm mild steel cold roll sheet. And you'll be making it the full width of the sheet. The sheets are, well, if they're metric sheets, they're 1200 wide, but if they're imperial sheets, they'll be 1219mm wide. So the very first thing I have to do is measure the diameter of the spigot, which the flue will drop into, and I find it's 125mm. So then we minus one material thickness from that, and we get 124mm. We times that by pi, and it gives us 389.6mm. We have to add to that the seam of 25mm. It's actually a 1-inch seam. It's an American seaming machine, roll forming machine. So what we're going to do is we're going to round the 389.6 to 390 and just add 25mm to it. And that'll give us a cut size of 415mm. This is for my flue at 125. Every student needs to measure their spigot after they've made it to check what size they're starting with in the first place. So my cut size will be 415mm by 500mm long. So the first thing you've done is you've got your sheet of material out of the rack, and you're not going to be able to use the backstop on the guillotine. Your 0.6 sheet, if you set the backstop to 415mm, when you put the sheet in, because it's so flimsy and flexible, it will hang down in behind the guillotine and it won't hit the backstop. It'll drop in under the backstop. So that causes a problem. The way to fix it is to use a notch like I've got on the screen. I've actually, this is the right-hand side of the sheet, and it's been done with a pair of right-handed gilbows. So you're going to put notches into it, and you're going to put the sheet into the guillotine and pull it back onto the backstops. So I will show you how to do that. Here are the two sets of tin snips. The left-handed ones are actually on the right-hand side of the screen, and the right-handed ones are on the left-hand side of the screen. You can see that the blade is higher on the left-hand side of the left-hand snips, and on the right-hand side the blade is higher on the right-handed snips. That's how you can tell the difference between a set of right-handed snips and a pair of left-handed snips. So I'll now show you in the video how to notch the sheet. So I've got the piece of metal. What I'm doing here is I'm using the left-handed snips to notch the sheet. You can see I put the snips in over the top of the tape, and at the last moment I move the tape out of the way. Don't cut your tape in half. It will happen at some stage. Turn the sheet round. I'm now going to use the right-handed snips, because when I step into the guillotine, that will be or step up towards the guillotine, that will be the right-handed side of the sheet. So that's notched at 415. To the guillotine, sliding it in and pulling it back onto the blade. And then you just want to slide it under as many clamps as you can before you actually do the cut. From this point we want to mark the bracket spacings onto the flue, on the outside of the flue, before we go any further. Okay, so my flue, when my flue is completed, it's going to come in with a circumference of 399mm, roughly 300, somewhere around 398 to maybe 402. If I divide that by 3, I get 133mm. So I'm trying to, if I've got my flue and I've got the seam on the flue, what I want to do is I want to put a bracket directly opposite, so an equal distance around either side. And then I want to step back. If I want to put my 3 brackets on it, well, they need to be at thirds. So there's going to be one on here, one on here. The distance around here, distance around here, and distance around here will all be equal distances. And they will be roughly 133mm. So what I need to do is I need to measure the width of my sheet, which I cut at 415mm. Divide that by 2, which is 207mm. 207.5mm, putting a scratch line there, taking a square up to that line, putting a line on here, and then I'm saying it needs to be 133mm out either side. So from there, 133 millimeters. There's my next line. And from the centre back out the other side, 133 millimeters. So when I come to put my brackets on, this is where I'm actually going to put my brackets. So from the outside edge, I should have, well, I've got 75 mil there, and I've got 75 on the other side. So the brackets are going to go on this line here, this one here, which is the centre line. It's the symbol for centre line, C with an L through it. And this line down here, that's my third one. So when I roll it up, those lines need to be on the outside. To put the groove seam on the flue, you need to get the large blue lock former. On the right hand end, when you're facing the groove seam side, is a stop-start button, and the handle must point towards you when you're facing the machine for it to be going in the correct direction. Into the rollers now, and the first thing I'm doing, the handle I'm winding there actually lowers and raises the bottom roller on the front. What I'm trying to do is just get enough gap so that the sheet will fit in, or the seam will go through the roller just now without being crushed. If it gets crushed, you're going to have to open it up with a screwdriver, so you just want enough clearance to get it into the rolls. And when I come to the end there, I actually have to close that gap up more and just wind it into the seam without crushing the seam on the other end. Otherwise it will slip on you and you won't get any traction with it. So it's just rolling it backwards and forwards until we get close to the curvature that we're looking for. Just takes a bit of time. You want to roll stuff slowly, don't rush into it. People tend to over-roll too quickly and damage, or not so much damage it, but make it out of shape. It's not so bad on very thin material like this, but if it's very heavy material, you should be very slow with your rolling and quite patient. So I've been saying that we don't want to crush the seam. This is the front roller. I've closed the gap right up. You can see the seam. We wouldn't want it to go between those two wheels, otherwise it would crush it down completely. This is the top of the roller, the top roll. At the back, the right-hand wheel roll goes up and down as you wind the handle, so we don't want the gap to close up at that point either, otherwise it will crush the seam. So it's been completely closed up here. You want the seams to either touch or even overlap by 10 millimeters. And what I'm going to do here is I'm going to lock it into place while it's still in the rollers. The hot rollers with a bit of tension on it will hold the seam in place, will hold the sheet, and it won't move too much on you. So I've just locked it in there, and now I can take it out of the rollers. This is what it should look like when you've actually clipped it together. To remove it from the rollers, wind the back wheel down, wind the front wheel down, just taking the tension off the rolls, otherwise it won't open up properly. So putting the flue onto the seaming bar. Now it's a railway iron, it's got a bit of a flat top, so I've moved it to one of the outside edges, the radius on the edge of the bar. You can see I've tapped down the first 75mm with a plastic mallet, and I just tapped the end level. Now I'm putting some centre punches on it. You want 3 centre punches in it within the first 75mm, and they need to be absolutely in the middle of the seam because you're trying to lock the seam together. When you go to put it through the Jenny later, it can declip if you don't put centre punches in it. So plastic mallet again, knock down the first portion, centre punch it, as I say, smack in the centre. then you can go along. You're doing a section that's 1200 millimeters long. You'll only be able to get half of it on bar. And you'll have to flip it end for end just like I have there, and do the other 600 millimeters, which is absolutely fine, makes no difference, but make sure you lock it on each end before you flip it end for end to knock it down. Be very careful how you use the plastic mallet. Try and use controlled blows, otherwise you'll start putting dents in the flue. So I'm just going to put another centre punch in here. I left one out just to show you. So I've rotated it to the right hand edge of the railway iron. Smack in the centre, give it a good smack with the centre punch, and then you can just press it down. From there we go to the jenny to put the ball swage on the end of the flue. Make sure you've got the switch going in the correct direction on the machine, and the ball swage needs to be 48 millimeters in from the end of the flue because your spigot is 50 millimeters. 48 to 50, that's the zone you want to be in. With our space already set to 48 millimeters, we can put the flue into the rollers. Now make sure that you aren't putting the swage on the end that you're going to put the brackets on. You can see on the right hand side I've got the lines where the brackets will go. Just remember that, you're putting it on the opposite end. You can see I'm just struggling to get it over the seam. Don't do it up too tight at the start. Just get because the seam's got 4 thicknesses of material, you have to go across it a bit lighter. Once you've got it started, then you can start to increase the pressure on it. You can see I'm doing it over multiple turns. You're not just going to try and do it all in one operation or one turn, otherwise you'll completely damage the piece of flue. You need to work into the ball swage very slowly, build it up. So I've got my piece of 3mm aluminium for the chimney cap, and I've scribed the circle. I'm just tacking it off in the guillotine on the outside line of that circle, so that I've got a circle cut with some rough edges that we're going to sand back to the line. In order to sand the aluminium disc back to the line that I've just cut on the guillotine, I've got a flap disc here, a zirconia flap disc, and I'm putting some bobbin grease on it, some tallow. If I just use the standard disc on the aluminium will bind to the surface, whereas you put tallow on it, and as it heats up it creates a lubricant, and it will cut the aluminium unbelievably quickly. You have to keep applying it. If it dries out, it will go back to binding up. Do the same for the cut-off disc. Put it on both sides of the cut-off disc. This is really the only time that you should use a flat disc on aluminium. I think it works brilliant on aluminium and not quite so good on mild steel. But anyway. So with the wax on the disc, you can start to sand up the outside of the disc. You don't need to clamp it down, just hold it. It cuts very aggressively. You need to be wearing your face shield, of course, plus some safety glasses as standard practice. It just works very slowly around the outside. You can see the disc has lost the wax off the surface and it started to get particles of aluminium stuck to it. At that point you need to stick some more tallow on it, and it will start to cut again. Once you've cut the disc, just give it a file up. So I've got my aluminium disc. It's been cleaned up around the outside. I'm just marking the V that's going to be cut out. So I've put the wax on the cut-off disc, and I'm starting to cut in from the outside edge there. I hold the cut-off disc vertical so I can see across the back to the right hand side to see the line. So I always cut from my left hand side towards my right hand side, and then when I do exactly the same when I go out the other side of the plate. So I pierce down through the plate, and once I've pierced through the plate I start to work towards the right hand side. I don't start on the outside and come back in, otherwise my line will be on the other side of the cut-off disc, and it's a lot harder to see when it's on the side of the grinder body or the sander body. So I always cut from left to right. Once you've done that, break the disc off, get a file, give it a clean up, and it's ready to be formed from there. So in terms of annealing the aluminium disc, you need to get a fire brick, put it on the table and put the aluminium on top of that. If you don't use a fire brick on the table, it will give you a false reading. You won't be able to heat the aluminium up properly at the right temperature. So what we want is a torch with a mixer on the end of it. We have these heating tips here. I don't want you to use one of those. They're too aggressive. They'll put far too much heat into it and you'll burn the aluminium. Just get a standard blowpipe. This is a number 15. Screw it into the end of the torch. Just adjust it. Should point slightly to the left when you're holding the torch. So for the acetylene, open the valve on the acetylene torch, wind the regulator in just a little bit, and then open the main valve. It wants to be on 70 kPa. Wind it up to 70 on the gauge, which is 10 psi. So that's that. Turn the valve off on the torch, open the oxygen valve on the torch, wind the regulator in just a little bit, and then open the main valve, and it wants to be on 70 kPa as well. So just winding that up to 70. These gauges start at 50, so they're slightly different to the acetylene gauges. So once we've got the pressure set, all we need is a flint, a little bit of aluminium over the surface of the sheet, a little bit of carbon, and it just acts as a heat indicator as we're actually annealing the aluminium. Doesn't take it to the exact temperature, but it gets us very close and lets us know that we're not far away from the temperature. Turning it up to a neutral flame and then burning the carbon off the surface. You need to keep the torch moving. Right, so in forming the cone itself, we're going to use a blowhorn stake, lock it into the vise. What we want to do is we want to hang the disc out over the end of the point, and we want the point sitting right on the centre, so we're going to try and rotate it around the point as we form it. First thing we need to do is when we form it, we just put it on the stake and put a little bit of effort into it and start to put some curvature into it. Well, when you get to the end, you can't do that because there's nothing to push on at this point, so we have to use use a plastic mallet. So I'll just show what needs to be done. Needs more forming in the top and less on the outside edge. Both sides, got to be done on this other side as well. Doesn't matter if you overform it, you can take a bit out later. So you can see the gap is starting to close up as we start to put the form into it. Trying to keep it uniform. If we have a flat spot, see a bit of a flat spot here compared with the curve on the end there, that needs a bit more form in it. So we just go back to those spots, put a bit more into them. Bit more at the top. Same on the other side. Gets this bow through here. That leg should be flat like this one here instead of having this curve in it. So we just need to put it on the stake and knock it flat. So we can actually pull it in together, get a vice grip on it. If the ends are slightly uneven, this leg here is slightly shorter than this leg. What you can do is drive that face forward on the stake. To get it to come to the point where it's actually level right on the very ends. At this point, you want to give it a good clean up. I've used some Miracle Clean. It'll just help when you come to weld it. So give it a good clean with some thinners. Then you want to wire brush the outside, brace of cleaning, do the outside, and then do the inside the same. This will help to make your weld run a bit better, won't be oxidized or anything. And then you should be able to clamp it together by yourself with a pair of vice grips, and you want to leave about a 1.5mm gap so you can get some good weld penetration down through the joint when you weld it. Lock the vice grips into a bench vise, put about half a dozen tacks down it, but you need to put some filler wire in there in case you need to stretch them out. So just load them up a wee bit with a bit of filler wire, 2.4mm filler wire. Put the cone onto the stake, just level the surface up, just tapping on the weld very gently, inside and out if you need to. Try not to stretch them too much, you're more just leveling them more than anything else so that you can actually weld a flat surface together. When I welded it, I started from the outside edge. I welded in the first 15mm at quite low amperage, down at 50 amps, because it's very, very easy to burn away the outside edge. Once I got past that first initial 15mm, I then welded all the way to the top of the cone at 80 amps. And when I turned it over, because it had a bit of weld on the outside supporting it, I turned the amps up to 85 to weld the inside. I was using a 2.4mm aluminium filler wire for the whole job. So having welded the cone, I sit it on the table and I can see that it's quite uneven. So if I was just to try and keep working at the shape, it would bounce and flex around. Once I've got a weld on it, it's got a bit of, it's going to stiffen it up. So I've got it on the steel table here, and I'm just going to use the plastic mallet to very gently true it up, getting it to sit flat on the table. Remember that the weld, when you weld aluminium, the weld actually effectively anneals it again, so it's very soft down the weld joint. The rest of the material, because I worked it over the stake, will have started to work harden, but it's still quite a soft cone, so you don't want to lay into it too hard. You just want to be very gentle with the hammer blows that you do use to try and true it up and get it sitting flat on the table. having levelled it up, we now need to grind the weld off or sand the weld off. I'm using that flat disc again. Once again, I've loaded it up with some tallow or bobbing grease, and I just want to take the weld off the surface. I don't want to cut into the cone itself. So just taking a skim off the surface or taking the weld down, leaving about, I don't know, try to aim for about 0.2 of a millimetre, leaving that much on the surface, and then it'll be cleaned up with the orbital sander. So I'm trying to keep the sander as flat as possible onto the surface. And now I'm going to take to it with the orbital sander. The orbital sander does not need to have bobbing grease on it. It goes slow enough, and the discs don't grease up with aluminium. They don't get clogged with aluminium. So you don't need to worry about wax of any description or cutting crease. So it takes a wee while to get through it. So I've sanded all over the cone, and I've got this little patch here where it's uneven. So I've got a piece of timber. I'm going to tip it upside down, and I'm just going to tap and try and level the surfaces up on the timber. The timber will let the surface move into it slightly. It's soft enough, and then I take to it with the orbital sander again, tear it down a wee bit more. So I've had to put it back onto the timber again. Sometimes you've got to do these things 2 or 3 times to get the level surface that you're looking for. Working from the outside with the sander, working on the timber from the inside, just backwards and forwards 3 or 4 times until you get the surface level. And you're not taking much off with the sander. You won't even have taken off 0.5 millimetre if you're very gentle with it. But I'm just working all over the whole surface. And once I've done that, I just give it a wee bit of a lick on the inside with the sander, nothing major. Take a bit of the sharpness off with the orbital sander around the outside edge, and that's it, finished. That's actually the cone finished. So it's just a matter of putting the brackets on it and actually attaching it to the stainless steel flue. Right, so when you cut a thin piece of metal on the guillotine, sorry, a narrow strip of metal, this is only 20 millimetres wide, it gets quite a long twist in it from one end to the other, and you need to be able to straighten it out before you start measuring or cutting it to size. So what you want to do is just put it into the vise, clamp it in one end of the vise, and just get a crescent and put the crescent on it, and you're just going to twist it back vertical. And you'll have to just move it along, take another bite, put it on the end again, and just twist it up. So it's going to take the twist out of it. So in drilling the stainless here for the brackets, got 1 hole on one end and 2 holes on the other. Put it into a small vise. It's got a little bit of a shelf on the bottom of the vise. Put it onto that shelf, hard down nice and tight. Do it up by hand. And the vise has this slot in it. You can just put a screwdriver or something in there, just do it up tight, and that's how you're actually going to clamp it. You do not want to hold on to it under any circumstances, because it's not so bad on a very small drill because you'll have enough strength to hang on, but if it's a big drill, it'll rip it out of your hands, spinning at 380 RPM as it is for this 5mm or 4.9mm drill, but for this drilling the stainless at 380 RPM, it's going to come around, it's going to cut your hand clean in half very, very quickly. It won't happen with this size drill, but that's not the point. You always clamp things thoroughly before you start drilling. Drilling stainless, you need copious amounts of cutting fluid. So what I'm going to do, turn the drill on, cutting fluid is on, light is on. And what I'm going to do is I'm going to line the drill up with the actual piece, and then I'm simply going to put the coolant onto the surface and drill straight through. Very simple. Get the coolant out of the way, undo the vise to the other end. This end here, I'm putting the bracket, I can drill the 2 of them at once. So just back into the chuck, doing the chuck up with a screwdriver in my case, bringing the drill down onto it again, getting it centered on the drill, cutting fluid back onto it. Cutting fluid out of the way, lining it up on the next one. And that's how you're going to drill it. You need to use the cutting fluid. Stainless is very, very hard, and the drills can, if you don't get the feed rate right and you don't get the speed rate right, they can damage the drill, and the drill causes friction instead of cutting, and it heats the stainless up, and the stainless will work harden. So the stainless work hardens, damages the drill. You're going to get a brand new drill, put it into the chuck, start to drill it again, but because the stainless is work hardened, it immediately rips the edge off the new drill. So the way to counter that is to keep pouring copious amounts of cooling fluid onto the surface, and it'll cut through stainless like a hot knife through butter if you do that. So what we need to do is put this fold in the bracket. I've already put the square on the end, so I've done my square fold on the end, and we need this fold at this point here. So what we do, the angle across here is 146.02, typical computer, taking it to 0.2. It's a ridiculous number. We want to go to 146. So what we do is we take 180 and we minus 146, which is 34 degrees. The straight line is 180 degrees, or a flat line is effectively half a circle, which is 180 degrees, minus the 146. So this angle in here is 34 degrees. So what we do is we take our protractor, and we've got our gradations around the outside here. So we're just going to swing it around to 34 degrees. And sit that on the table, and then we're going to take an adjustable bevel. It's got a screw on the end. Undo the screw, and you're going to put it hard onto the two faces so that it follows the angle. So I'm just going to tighten it up a wee bit, and I want it sitting tight onto the protractor, right down into the corner, so that we get the exact 34 degrees that we're looking for. So I'm putting the bracket into the folder up to the line that I want to fold on, clamping it down. Remember that we want to be going square into the folder. We don't want to be on an angle either way. We want to be absolutely square into the folder. You can put a square alongside the actual piece of steel, standard square, put it alongside the piece of steel, and get the piece of steel just clamped in under the blade. Open this end up, put it on the line, get it close to the line, put the square in there so that I know that I'm actually folding it absolutely square. Just going to do one at a time at the moment. So once you've got the steel into the right position and you want to fold it square, you're going to take the bevel and you're going to sit it on the front folding leaf, and you're just going to bring the folding leaf up until the blade is actually vertical in the vertical position, and that will give you 34 degrees, and that's where you want it to be. So put the adjustable bevel hard on the bed. When it gets to the vertical position, that's 34 degrees. So we've got our flue here. Get a scratch block, scratch the line up to which the bracket will go to. Clamp the flue to the table. Just use a standard pair of C-clamps. Don't have the ones with the feet on it. When you clamp it to the table, the big wide feet would put a big large dent in the flue, and we don't want that. So we're just going to put the bracket dead on the centre line so that the two holes that we drilled were on the centre line. We want that centre line that the holes are on to be on the centre line that we drew for the three brackets on the flue. So once that's in that position, just going to get a standard pair of vice grips clamp it to one side. It'll lean across one side, but that's no big deal. We can still get our holes into it. So we've got our 4.9mm drill bit, and we're going to use a pistol grip drill. So you're just going to put it into the chuck and do it up. Now these chucks are keyless, and they tend to let go. So it's in two halves. Grab the back half and do it up as tight as possible. And you're just going to drill through the surface. So make sure you've got safety glasses on. Notice I'm working the trigger on the drill quite a bit to slow the drill down. I don't want it going too fast. On the inside it's going to have a bit of swarf. I want to take that off with a half round file. And instead of putting my bracket on the outside, I'm actually going to put it on the inside. I think they look better on the inside. So we've got our holes set up. And what we're going to do is we're going to rivet them on. So second bracket onto the surface, on the line as accurately as possible. Got it upside down again. So on the centre line, clamp it. I'm going to put that one on first. Bracket could move on me. Rivet up. That's going on the inside, and I'm going to have it going the right way. Oh, okay. So what I'm going to do is I'm going to put a little mark there so I know where I'm drilling. Otherwise I could muck it up. That drill centre is actually almost the mark anyway. So clamp them there. Bracket on here. Where's the light grip? Drilling the next hole. Taking the clamp off because the head of the riveter is hitting it before it's getting down flush with the surface. I don't want that. I'm not doing very good with this because it's just starting to... Bloody glasses. So quite a few students put the brackets on upside down or back to front. So if you do that, you need to drill the rivets out. So what you want to do is you just want to put the drill into the rivet and move it around as I'm drilling. Basically, we just want to remove the head only. So got the bracket off. What we want to do then is to punch the rivet out. Because the nail is in the rivet, if you were to take that nail out of the rivet, you could actually drill the rivet out very, very easily. But because the nail is actually stuck down in the base of it, when you put the drill right onto the end of the nail, it actually damages the end of the drill bit. So if you drill the head off just like I did, you can actually punch these tails out of it, just with a centre punch and a hammer. Just knock them back through. There's one gone, second one, that's the second one gone. So we're back to the original starting position. Put it on the right way this time, Mark. So as you can see, we've got the brackets on there. Now what we want to do is just to sit the Chinaman's hat on top of it. So the Chinaman's hat just sits on here. It's not the most ideal way to line this up, but for the purposes of what we're trying to do, you want to put the spirit level through one way and check that it's level. The tables in here are pretty true to the floor. The floor's quite good in here. So I'm getting it level one way, and then I'm putting the spirit level at 90 degrees for the previous one, and just bringing it up to it. Just need to make a slight adjustment. So I'm putting the Sharpie up in here, and I'm just marking the holes where they're going to be. Just mark them on all three brackets. And then what we'll do is we'll take it off. And I want to mark a bracket which side it points to. So I'm just putting a mark on here so I know that I'm putting it, when I put it back on, I know which side it goes on, and I'm going to take it off and drill it. So I've drilled my holes and I want to put it onto the surface, but I've missed one hole. I haven't picked up the mark for it. So what I'm going to do is I'm going to put it on, and I'm going to use these devices here. They're called a rivet toggle. I use them on aircraft and the aviation industry when they're putting hundreds and hundreds of rivets in an aircraft panel. Being aluminium, you can't put half of them in and realise that it's in the wrong position and try to drill them out, because you can't drill rivets out of aluminium properly without damaging the sheet or damaging the holes in the sheet. So what they do is they put hundreds of these things on. It just drops through the surface into the hole, and it just pulls back and does up, and that will hold it in position. One on the other side. Got another one here. Yeah, do it up. So I've got it clamped on two toggle rivet toggles, and this is my last hole, so I need to get the Sharpie in here again. Just undo the toggles, push them back in, and they come out. So quite handy for setting things up if you haven't quite got it set up properly. There's my hole. I'm going to drill the hole with the drill. Aluminium is very soft, you can run it at full speed. And you get the swarf on the back face of the hole. I'm just going to put the drill into it, give it a wee bit of a twist round, and it will clean the swarf off it. You could use the countersinker like we did when we drilled the stainless steel brackets, but this will suffice for what I want for this. So I'm going to I'm actually going to rivet straight on this time. I'm not going to put the rivet toggles on because I don't need them. So rivet straight into here. One. Two. And that is our flue completed. If you forget to put the marks on it to put your brackets on, you can use this circumference rule here. You can wrap it round the flue pull it tight, and you can read off what size it was. So I said when I made it that it was about 402. It's actually reading here at 392, so it's slightly out. So 392 divided by 3 would be about 130.6. So what I would do is I would mark the centre of my seam, and I would measure from there around that way, 130.6. Oh, sorry, start again. 130 divided by 2, 130.6 divided by 2 is 65.3. And from the centre of the seam around the other side, 65.3. Once I've got those two brackets, I would then measure 1/3, which is the 130.6, and I'd have the bracket right at the very base. So I'd have my 3 brackets on it. To do that, you can take the tape apart. You know, you can set it on, say, 600 here and hold it tight while you measure around here, 65.3, and put a mark. And you can do the same. Put on 500 this time, measure around here 65.3 and put a mark with a scriber. So you could actually put your bracket positions on it after if you wanted to, just by using this circumference rule here.